This video is all about an important lesson about scatter and regression. While doing it in Excel, that too when you have a data set that is exhibit zero value, then the very chances that the Excel might return the different slope line, right? You need to be very careful. Let me show you why it is so important, right? So let me go ahead and take this one. There are two ways we can do. Of course, the formula part is correct. So, for example, let's say the scatter relies on the R value, right? The relationship or correlation, right? Correl we can put, and then I will take with the Y, that is my output, the weight gain, and how much consume of calories I consume, right? And this is the value it gives, given 96.97. Anything about 17 above or 18 above, I will say it's a strong correlation. So that means the weight gain is depend on calorie, how much weight we consume. The same thing you can do it in regression. So in the regression, when it comes to that, you can just either you can apply the formula called R square, and this is Y, comma, this is X. In other word, you can also prove that one. So this, if you square up cap 2, if you square up, you will end up getting the same value, right? If you see here, both values are same. Either using R square you can do, or you can just simply Corel value if you just square up. For example, another way, I'm directly doing apply formula, Corel, and, this one, directly I'm applying it cap 2. So you get the same value. So you have three options. So any of the value, and the value looks to be same, right? We can also test it in data tab, Minitab, Stat.Blue. It looks to be fine. But where you need to be cautious about is that you need to be cautious about the slope line. Why I'm stressing so much? Let's say I'm just taking this data and going to data and data analysis. In the previous video, we talked about how to enable it, data analysis, and I'm just taking it regression. Let me go directly to regression. So you have various options. So, but we are interested in regression itself. So just scroll down. You will find the regression beneath the this one, rank and percentile. You have regression. Just take it up, and it is telling that what is the y. Y is the output, and x is the input. And then label, I have not given the label. So confidence is 95 is fine. I'm going to store the result directly here, right? I'll give okay. Now you see that the value it has given the multiple 96.97, the same value it has given. Even if you want to convert in percentage, you can convert. And then R square value it has given. So pretty much the same R square value, we got it. And adjusted R square, the standard error observation number. And then it has given that regression one. So ANOVA table, and the p value also is given. So p value is 0, almost 0%. That means it's significant. By we can, we can tell through that R value, since it is greater than 80, or we can tell through that the f value or p value also, or significant value also, right? And now we are interested in the slope line. This is one way. I think as far as the formula is concerned, there is no contradiction. So where you need to be careful is that, so while let's say I'm just using this data set, I'm trying to drop the regression. Let's say this is the one, it has automatically given that calories. Let me give okay. And now what I have done, so the scatter is ready. This scatter, what I'm doing it, I'm just adding it layout 9, right? Layout 9 will offer the regression one, right? Linear one. And default is a linear one. That is still fine. 94.03. This is fine. I mean, as far as the regression is concerned, this is okay. And then it has given this value. So just copy this value. and I will paste this value here somewhere. So what it has given is that y equal to m. M is the slope line. It has given the slope line is 2.0305, and x we can input that x, that is independent factor, and c is 1672.1. Let's see that whether the same value we get it in any other platform. Let's say I'm just taking it one example of the stat.blue. Let me just keep it here. So I'm just going to that stats.blue, and then I'm clicking its linear one, and I need to copy paste this value. Calorie consume. This is my input. Output is weight gain. Okay, and then I'm just selecting that output, and it is also I'm just selecting this value. Okay, include the regression equations, everything. So null hypothesis that both variables are same, and at least one of the variables are different. That's what it says, right? Greater than or equal. Okay, 4 decimal is fine. I'm just clicking it here. Spontaneously, it has given that value. So as far as the correlation and regression, you have the same value. This is good. And it has given the residual plot. It is also given that two variable. It has given the residual plot. Histogram also is given. Normally plot looks to be okay, and box plot, and this is the equation you get it, right? So y equal to a alpha plus beta into x. In other words, y equal to mx plus c, right? So only the verbiage is different. Y equal to c plus m into x. In other words, okay. And then you have given that standard deviation value, standard error, and all that value it has given. And if you see here that equation it has given this one. Go back. So equation is given here, right? The weight gain is a y, and 0.4631 is an actual value, but it has given different value, right? So if you look at here, I'm just copy pasting it from here. I will just copy it from here. This is the equation given by without equal to, I'll keep it. If you see here, the C is completely different here, right? I mean, here it is giving in minus value, right? Just like C has got a different value in Excel, and this is stats.blue, and we'll write down the comment here. So this one is stats.blue, and slope line is also different, right? So I mean, here the slope line is very, very different here, right? 0.4631, and the x remain to be an independent factor and all that, right? So what could have been happen is that, so this value, right, the Excel is getting rid of that anything zeros, it is getting rid of it, and then it's trying to do it. Let me prove it to you. Let's say I'm just skipping this one, and wherever the x is, I mean zeros is there, I'm just skipping this one, right? And then I'm trying to add this up value here. I'll cut and paste it here. Let me run that one, and probably you will get the same value what Excel is giving, right? The only thing is Excel is skipping that value, right? So weight gain, and just keeping it, and then I'm also keeping it calorie consumed, right? And perform the similar one, right? Calculate and thing. Now you have that value, and let's see that the equation. You see again it has got changed. So that means so whatever the Excel is performing, it is not accurate. So don't do it in Excel. But however, you can use Excel to calculate the critical value like R or R square, but do not use it this for any further calculation. Let's do it in Minitab. I have a basic version of Minitab. Let me open that up. Minitab I'm opening up. Let's see what Minitab is giving that value. Okay. And before that, I will just undo that one. Right now, it has the original value, and we suppose, let's say what Minitab is giving it. Minitab, just opening up this Minitab 17. Minitab is getting open. And what I will do is that I will just copy this value. So Minitab has got open. So now what I will do, I will just go back to this Excel and then I will copy this one. My aim is to find what is a slope line, right? So stat, and then of course regression, fitted line, and linear. With Excel is producing the linear, so linear is fine. Weight is output, and the predictor is input. So two time I click, so two time it is open. So calories is input. So this linear is fine. It's giving okay. You see that the 94.1, and then this is the value we have got, right? So let's copy this value and let's keep it back to Excel. Let's see what Excel has given that one, right? So maybe equal to this. So you see that exactly the same value what you got 7, exactly 6, right? So exactly the same value Excel has Minitab also given, same like this, and then this also will is same. So the only odd out here is that Excel has given different line, just because one of the reason could be due to zeros, and then so we do not use Excel, and most of the statistical calculation Excel may not be accurate. So use the exact tools of statistics. Okay. So one more topic which I wanted to discuss is that, okay, let's say whether we are using these or these doesn't matter because both are same. And let's say we are giving that, I'm going to consume, let's say, supposingly, let's say what will happen if I consume, like I'm just adding it like 1,000, 2,000, so on, right? So I'm just giving it here. Okay. And then I will keep this same value across the board, and I will keep the same value across the board. Okay. And then y equal to mx plus c, we can also predict that value, right? So using any of this value, we can predict it. Right? So y, this is y we need to determine. M, this is 1. And maybe what I will do, I will just put this in the bracket so the calculation doesn't get messed up. So slope times, this is my data. I mean slope line, the independent, the calorie consumed. And then I need to, from the formula, I need to give plus into minus minus. So I'm gonna directly give minus, and I'll take, maybe I'll give that plus here, and then I'll give minus here. So that means even if I consume 1,000 calories, is not going to gain any weight. So minus is nothing but 0, right? And even if as I go up, right? For example, let's say as I go up, right? And let's say I'm just adding it calories here, and then 2,000 calories. That means 172 gram I will put up. 4,000 is this one, right? The same if you do it again, like similarly, if you do it using this data set, let's say copy this data, put it up in wherever, Minitab or data tab is anything's fine. Keep it here, and I will just keep it here. This is my x, this is my y. This is y, and this is x, right? So it's supposed, because we have derived from the formula, it's supposed to be 100, right? R square supposed to be 100. Let's see. Let's check that up. We can take it y x is x. Exactly 100. So it is, because we have calculated, so it must be the same equation, and then we got the right. So this is how we can cross check and predict and all that. That's also one of the reason why we say regression is a better optimizer. We can optimize the value. We can just predict the value. Even in the Minitab, it has that symbol. For example, if you go to assistant menu and you have that regression, and if you have that, you have simple regression, multiple regression, and then you also have the response optimizer, right? So what you want to optimize? Let's say you want to optimize y using x, and then what is your category value, and then it also gives that interaction, right? So like this, you can continuous x predictor, right? So maybe we don't have a multiple one, so we cannot do it here. So we can do that value here. So what I meant to say was that we can easily predict using this one. Let me lay out this one. I'm just taking it here. This is, I have created another, right? So you see, this is the one, and previously we have done this one. And please remember the summary, the short summary of this presentation is that don't use Excel and then try to use stat dot, Minitab, data tab. All that will give you similar lines, similar scope one, y equal to mx plus. I hope you find it useful. Please do like, share, subscribe channel. You have a wonderful day.